Good morning to everyone. Myself KV Jikumar. I'm from Mechanical Engineering. Today the presentation on physical layer security in evolving optical networks. About the introduction. Physical layer security plays a crucial role in safeguarding data transmitted over optical networks. Here, what about this? Security plays a crucial role in the safeguarding data and transmitted over optical networks. Physical layer security. Evolving optical networks require robust security measures to combat increasingly sophisticated cyber threats. Optical networks require robust security measures to combat increasingly cyber threats. By leveraging the physical properties of light, physical layer security offers enhanced protection against eavesdropping and data interception. Common securities attacks in the OSI layer models, 7 layers, 7 applications, 6 presentations, 5 sessions, 4 transports, 3 networks, 2 data links, 1 physical attacks, 7 applications export, 6 presentations finishing, and 5 sessions hijacking, etc. attacks, and session side jacking malware, 4 transport. The recommendation is just TCP session hijack, struggles and flood and land attack. 3 networks, man in the middle, stump attack, ping of death, teardrop, 2 data links. They are spoofing, MAC spoofing, and MAC flooding and bland hopping, 1 physical sniffing. Next, optical fiber communication. Optical fiber communications forms the backbone of modern resolutions and networks. Light signals carrying data travel through the optical fibers and making them unreliable to interception. Physical layer security techniques aim to secure these optical transmissions from potential attacks. Non-attack and avoid are soft attack. Note it is assumed that the hardband high or jamming signal it can be instead inserted on an legitimate connection. Worst case in bad jamming attack is inserted on C and aggregates 4 connections. Worst case in bad jamming attack is inserted on any degrades connection C and C. Soft awake attack awake, not non-attack awake. Next, quantum key distribution QKD. Quantum key distribution is a cutting-edge physical layer security techniques that uses quantum principles to establish secure encryption keys. Non-attack aware RWA. By leveraging the properties of quantum mechanics, quantum key distribution enables secure key distributions immune to interception. QKD enhances the security of optical networks by providing a highly secure exchange mechanism. Non-attack. The case in band jamming attack inserted on C and C degrees connections to C2, C3, C4 and C5. Next, covert communication detection. Physical layer security techniques can detect covert communication attempts within optical networks by analyzing signal characteristics anomalies indicative of covert channels can be identified. Detecting covert communication helps prevent unauthorized data extraction and ensures network integrity. Next, the physical layer security techniques can detect the communication with optical networks. Here we the to the convert channels can be identified and extractions ensures network integrity. To the example effects of high power immediate attacks. A mixed modulation attack in efforts with pain equalization chances may still occur before reaching the steady state. Next, secure transmission techniques. Secure transmission techniques such as encryption and authentication bolster physical layer security in optical networks. Symmetric encryption, secret key and encryption to description and cipher text and plain text receiver and sender. Here about the algorithms safeguard data by encoding it a secure manner to preventing unauthorized accesses. And Physical layer security in optical networks is an encryption such as the secure transmissions techniques. Mechanism validate the identities of communication endpoints, ensuring secure and trusted transmissions. Here the plain text, receiver and sender, and encryption to description. Here the main part of secret key and symmetric encryption. Next, resilience to cyber attacks. Physical layer security enhances the resilience of optical networks against cyber attacks. Security the transmissions medium itself, by physical layer security adds an extra layer of defense. What is a cyber resilience? Identify, protect, detect, react. Because it was the first one is identity, and second one is protect, and third one is detect, and fourth one is react. Combining physical layer security with traditional network security measures create a comprehensive defense strategy. Next step, key exchange protocols. Key exchange protocols are crucial for establishing secure communications channels with an optical networks. The protocols are very crucial for the communication channels, and protocols like Diffie-Hellman key exchange facilitate secure key established between communicating parties. Protocols are like different element key exchange and facilitate secure key established between communicating parties. Ensuring robust key exchange protocols is essential for maintaining the confidentiality and integrity of data transmissions. Here the A agree upon two numbers, prime number and generate of P to 13, G to 6. Private is equal to 5, private equal to randomly generate a private key, calculate public keys, exchange public keys, calculate the shared secrets. Next topic, dynamic security adaptation. Evolving optical networks require dynamic security adaptation mechanisms to counter emerging threats. Evolving optical networks require dynamic security adaptation mechanism to counter emerging threats. Common security attacks in the OC layer model, 7 layers attacks. The applications is expert and adaptive physical layer security solutions can adjust security parameters in real time based on network conditions. By continuously monitoring adaptation security measures, the optical networks can effectively mitigate evolving security risks. And next, multi-layer security integration. Integrating physical layer security with higher layer security mechanism enhances overall and network protection. Multi-layer security approaches combine physical and data links, networks and applications layer security measures. By integrating security across multiple layers, optical networks achievement comprehensive protection against diverse threats. Here the common security attacks in the OC layer model. 7 layers applications is presentation, 6 presentation, 5 sessions, 4 transport, 3 network, 2 data link, 1 physical. Next, conclusion. Physical layer security. Here the attacks are export 7 applications attack, 6 presentations finishing, 5 sessions hijacking, extracts and sidejacking malware. Recognizing the dogs, TCPs, hijacks, fragile, sign for land attack, man in middle, slump attack, ping of death, teardrop, good data link, spoofing, max spoofing, blan hopping, one physical sniffing. Conclusion: physical layer security is essential for ensuring the confidentiality, integrity of availability of data in optical networks. Here we know about the essential for ensuring and the confidentiality here in data in evolving networks. Leveraging advanced security techniques such as QKD, encryption and convert to communication, detect strengthens network security. Continued research and innovation in physical layer security are vital to address the evolving threat landscape in optical networks. Assuming P1 is used to support communication between the DCS fiber cut, one would trigger protection or registration Switching to P2, then fiber cut P2 world is which does not meet the latency requirements. Note, depending on the implementation, the traffic might stay on P2 even if is P1 required fiber cut P2 and fiber cut P1. And